Okay, hello everyone. This is Joe here. We're going to continue on with our series. So we finished talking about all of the O of n squared algorithms, and so now we're going to move on to the O of n log n algorithms, merge sort and quick sort. This video is on merge sort. Um, Again, if you haven't seen the first intro video with the bubble sort, you should go ahead and check that out first, as that kind of explains what's going on in these videos. Okay, so oh, also I kind of changed my recording setup here. Hopefully it's for the better. I'm not really sure. I need to be able to record my cursor here, and so I changed my recording setup. Hopefully you can still hear what I'm saying. Okay, so merge sort is uh, the first nlogn sorting algorithm that we're going to talk about, and it's a divide and conquer algorithm. And so it's recursive in definition. The basic idea of merge sort is we're going to break up our array into halves, and we're going to keep on breaking that up into halves until we reach our base case, which is just one element array. And we're going to say that that one element array is sorted on its own. Then, once we go up the recursive call stack, we'll have like the two halves that's been sorted recursively. And at the lowest level, that's just going to be, two one-element arrays, right? And then what we're going to do is merge those two halves into a sorted portion of the array, and then return that up again to the next level in the recursive call stack. And from there, we'll merge the larger two halves, and it will keep on going up and merging these two halves until eventually we'll merge the two halves of our original array, and you'll have the entire sorted array. So just because of the nature of breaking it up into halves, that's where we get our runtime complexity of O of n log n. And so let's just run through a few iterations of this and watch merge sort in action. Alright, so here's one run through it. Okay, so you can see that's our base case. We just sorted this one element array down here. The algorithm basically split it up into half here and half again until we hit this just one element array. And then let's do one more run. Okay, so here's our next base case. We just sorted this guy here. Well, let's do another run. And again, we sorted here. So at this point, when we first divided the array, you see we have a total of 6 plus 7. So we have 13 elements here. So when we did the first division, it's integer division. So 13 divided by 2 is 6. So the first half that was broken down is these 6. And then the second half is broken down as these 3. And then that was further broken down into this one element array, and then this two element array. So we just finished sorting these two elements on its own. And so if we do one more run, right, that just sorted this two element array here. I mean, they're already in sorted order. You didn't see any visual change, but now this next run, it's going to sort this entire three element portion here. And so obviously, this guy, the minimum is going to come to the front, and then this guy, and then he'll go to the end. So we'll have this little portion sorted here after this next run. Okay, sure enough, there we go. And then, we'll repeat the same thing with, the next half you can consider is these three elements, and they'll be sorted in the exact same order that these three were done, because this is like the other half, right? So let's just run through those. Alright, so we just finished sorting this half here, right? And so now that we have this first three as one complete half that's sorted, and these three, that's the other half that's sorted, now we're at the point where we've gone up the recursive call stack, in merge sort is going to merge this half, these three, with this half, these three, and make those 6 in sort of order, and that'll be the first half of the original entire array sorted. So let's check that out. And there we go. And so now we're halfway done with the job. And then so the other half, all the blue bars here, which haven't been touched yet, now we're going to pretty much repeat exactly the same thing for this second half. And we're going to do the exact same steps here. So I'll just run through several of these iterations. So that was, these 3 was the first little half here that was sorted. Now these 4 here is the other half of, you can kind of think of it, I guess, like a quarter of the original array. So we're going to go ahead and begin merge sorting this little portion here. And so now that we finished merging this half, we're going to take these 2 halves, these 3 and these 4, and merge those together. And so now we're at the final step of our algorithm. This was the original recursive call. We just have this first half. It's now magically sorted through recursion, and then the other half is also magically sorted through recursion. And you've seen all that happen. It's now the final merge. We'll go ahead and take these two halves and merge them into the final sorted array. So let's go ahead and finish this.